All right, we are asked to do the derivative of this. Okay, so if we're looking to do the derivative, there's a couple different approaches that we can do to this, and I don't know if one's necessarily easier than the other. But if you were to do this derivative, you have a quotient rule, but then you also have a product rule within the quotient rule. So maybe you're not excited about that. So there is one thing that you can do that might make it easier, just kind of depends on your perspective, is when you have something that this is this complicated, you can actually bring in the natural log to potentially make it easier. So we'll see what you think. All right, so what does that mean? We are going to natural log both sides. So already it's like, okay, we just messed with the left side that didn't need to be messed with, but that's okay. So we're going to natural log this whole thing. So here's what happens. The left side is what it is. So we have the natural log of f of x. What happens on this side is you have all these properties that are going to kick in. So you have pieces that are multiplied together so you can expand. Normally we take multiple logs and condense them because then we're solving this. But we're trying to do a derivative, and I don't want to do chain rule and product rules and things like that. So I can use these properties, and my last property that I'm going to use is the fact that logs don't need to keep exponents. And so I can pull that exponent down. So here's what I got. I have that I can separate these into the natural log of x squared plus 1 to the 4th plus the natural log of e to the x minus, because that's in the denominator, minus the natural log of x squared plus 4. All right, so now when I do this derivative, I'm just going to be doing derivatives of individual things. There is one other little piece that I can clean up, actually two pieces. So I have the natural log of f of x equaling, I can pull this in front, so 4 natural log, so I don't even have to do a chain rule on this, like the chain rule within a chain rule. I can treat it like this, right? And then this piece, because that matches that, this just becomes x minus natural log x squared plus 4. All right, so I'm now going to do the derivative with respect of x to that. Okay, so now we're ready to go. So to do the derivative of this is actually not as bad as it looks. Doing the derivative of f of x is 1 over f of x times the derivative. It's the chain rule. All right, if I do the derivative of this, I get 4 times derivative of the natural log is 1 over x squared plus 1 times the derivative of the inside. So there's the chain rule applied. Right, and then the derivative of x is 1 minus the derivative of this is going to be 1 over x squared plus 4 times the derivative of the inside, which is 2x. So as far as doing the derivative, that's it. We would be done. Our goal is now the algebra part. The algebra part is we need to isolate this because we're trying to find the derivative equation. So I need to simplify this a little bit. And this, I actually know what this is because f of x equals, before I natural logged it, that piece. So we're going to pull that over and replace. Okay, so a little bit more left. If I could try to put this stuff together, let's do a little bit of algebra and see how far we can go with it. So if I put this together, that's just going to be an 8x over x squared plus 1, and then plus 1 minus, this just can become a 2x over x squared plus 4, and that is equal to 1 over f of x times the derivative, f prime. And then I'm going to clear this out, which means I'm going to multiply that to both sides so it can cancel. I'm going to multiply it to both sides so it can cancel, at least on that side. So we are left with this piece times our original f of x. Again, our original f of x was that. So this piece, 8x over x squared plus 1 plus the 1 minus the 2x over x squared plus 4 times the original x squared plus 1 to the fourth e to the x divided by x squared plus 4. We are not going to try and simplify it any further than that. All right, so I think it ends up, I mean, no matter what, this is not an easy problem, but I do believe that when you have something that has just too much going on with products, within quotients and things, you can always bring this in, which breaks apart these pieces. So individually, they're not nearly as difficult to work with. And then that last piece is you're always going to have this, where when you do your derivative, because you log both sides, you're always going to have this 1 over x times its derivative, and you're going to always try to isolate that, which means you're always going to bring the f of x over. So you're basically always going to have that look right there. And then you just sub that out, and then that's it. So I would rather do that, even though it's a difficult process, it's still, I think, much better than having to do the product rule within a chain rule with kind of some ugly pieces. And we have a chain rule, we have a quotient rule, we have a product rule. Really, we have all three of them all mixed in this problem. So that is just another approach, another look at how you can do something.